Hey, everybody. Welcome back to AI Diatribe. I am Jason Lowe, your host, joined today by my co-host, Matt Conweiser of IBM. Say hi, Matt.
Hi, Matt.
He
Or
did it
Jason.
again.
And everybody else.
He did it again.
I mean, if it worked the first time, keep going.
And today we are doing a special episode, just the two of us, because there has been something pretty significant that has happened in the last little bit as it relates to AI, specifically proliferation. So the big deal that has happened in a nutshell is that Google has come up with a really big innovation that affects the efficiency of large language models. Basically, Google has come up with this thing called TurboQuant. It's basically a training-free compression algorithm. And what this does is it is really targeting the single biggest physical bottleneck in making AI bigger, and that is this thing called the key value cache, or KV cache. Now, there are a lot of you that are probably going, well, what the heck does the KV cache have to do with me? So what this means is that as large language models, as they're handling these larger conversations, what we call long context conversations, like where you start a prompt and you talk to it forever. Have you ever noticed as that goes along that sometimes it forgets some of the things earlier in the conversation? This is problematic because AI needs to remember everything previously in the context of that conversation in order to be really effective. And so what happens is the memory requirement that is necessary for that to happen with AI large language models, this really grows quickly. It really makes things really expensive when it comes to actual GPU consumption and GPU RAM specifically, and it really slows the model down. So as the conversation gets larger and larger, what happens is that most large language models will actually cut out sections of the conversation to make the conversation more efficient so that it can respond a little quicker. In some models' cases, you can actually make sure that it's cutting off or truncating off the back end of the conversation, so it's just paying attention to the stuff that's most recent, or so that it pays attention to the beginning of the conversation and the most recent portion of the conversation, and it's cutting out the middle section, which gets bigger and bigger as the conversation goes along. So that is what AI large language models do to keep things up to speed. What the TurboQuant innovation does is it compresses the short-term memory stuff by 6 times with 0 measurable loss in accuracy. So what that means is that as the conversation gets bigger and bigger, it doesn't have to cut down as much, if any at all. So this also increases the attention processing by up to 8 times on hardware like the NVIDIA H100 chip. So this really makes it so that these long context conversations that have previously been considered unrunnable, they actually can be moved into production ready tools, and they can run on significantly cheaper hardware. In other words, not these big massive AI chips that are in these factories, but maybe something a little bit closer to a local or edge device like your laptop, or maybe even your phone. So this is really kind of neat because now we're talking about enterprise AI capability. 2 big impacts. Number 1, how much centralized cloud infrastructure is really going to be needed for how long? We are now moving into an era where AI is getting powerful enough to run on local edge devices that these really big cloud infrastructure elements, of which all of these data centers that are proliferating are part of, may not necessarily be required as we get better and better and this innovation improves. But then the second aspect of this that's worth considering is that now we have these good large language models that we're giving local control. We're giving them autonomous agent capability, much like the OpenClaw phenomenon, where it can actually control your local computer. Heck, Claude, which is one of those frontier large language models, they now have a capability of controlling your Mac locally. Even though it is a cloud-based enterprise model, you can actually put things on your computer that will allow Claude to work like an OpenClaw autonomous agent locally on your Macintosh computer. That's what allows it right now. So now that I have gone ahead and really gone off on all of these things that have happened, we get to start talking through the different impacts. Matt, what did I miss in that long-winded summary of these recent events?
So, I mean, I think you got all of the key points, but there's been a couple of things that have happened in the past week or few weeks that also build this case as a thing that we need to discuss. And the first one is that Flash MOE is mixture of experts. It's a collection of models that all work together in different ways to solve problems. They were able to demonstrate that a nearly 400 billion parameter model was able to run on a laptop. Now, that plays directly into quantized models because that's how they're able to do it. The other big thing is that people were experimenting with the iPhone 17 Pro and were able to get that to run a 400 parameter model by offloading a little bit of the workforce onto an external SD card. The reason why all of this matters is because if you remember this little thing called DeepSeek version 3 that came out and shook NVIDIA's stock price and market cap to the core, because people realize that maybe we don't need H100 GPUs in order to train these giant models. Now, with Google's research and all of the other things that are happening now with the iPhone 17 experimentation, with the Flash MOE, we're starting to see the same thing again, but now not just about training, but actually running these models. And that's a much bigger deal, because if you think about it, you only have to train a model once. You train it and you push it out. And the reason why there's been 4 or 5 oligarchies around AI is because the amount of compute and data center resources needed to build and train those models is massive. And DeepSeek said, well, actually, you know what? Yes, still incredible feats, but maybe there's a way to do something similar, not exactly the same, but do it in a much smaller scale without the $120,000 card GPUs piece. Now, fast forward, and we're seeing that now to run these huge models, maybe we also don't need rack servers and data centers. So now we can train the models for significantly less using different methodologies than the standard brute force training. And we can run them on significantly smaller hardware footprints because quantized capabilities are giving us that possibility. And I think that's where we start to ask the question of, just like Amadei asked a few months ago, is what's the future of SaaS providers if Claude Cowork can do everything? Now we ask, what's the future of data centers and public cloud environments if we don't need them? And I wonder, couple that with the new Mac announcement of the $600 MacBook, right? That runs the same chip, I believe, as the iPhone 17, which can now apparently run 400 billion parameter models. I mean, it makes me wonder, are we due for yet another massive industry shakeup?
This is not only about cloud computing also, but one of the things that is really significant, at least lately, is that there has been a bit of a RAM crisis, right? I mean, this is what has caused Micron, Samsung, SK Hynix, their stocks to really go through the roof because there's been a crunch for RAM, not only for training, but mostly for the actual operation. As you said, there's the 2 different types. There's the training and then there's the utilization or the inference. And this news, when it broke about, Google's new development, it happened as we're recording this, folks. We're doing this on the morning of Sunday, March 29th. And so there may be some things that actually develop between the point that we're recording this and when it gets released on Thursday, April, whatever, I think it's going to be April 3rd or something like that. But back when this news broke on March 25th, 26th, which was just a couple days ago from now, that's why the stock market, specifically in the memory area, really kind of dipped, because the market is fearing this situation where you could have up to a 6 times reduction in the memory needed to do these different things. It would really kill demand. But it's also very interesting because, Matt, and I know you're going to love this, how does Jevons Paradox come into this?
Oh my God. That's a trigger. You know this, right?
I do, yes. That's why I said it.
All right. So before I answer that question, let me give everybody a 30-second primer on Jevons Paradox, because if you've not heard this before, you have to understand what it is in order to get the significance of it. So imagine for a moment that everybody uses incandescent light bulbs in their houses and they all decide to turn them on all the time. That's going to create a significant demand for electricity. So the providers of that electricity have to ramp up their production to provide the power to all of these incandescent bulbs. Now, everybody switches to LEDs. Same brightness, but consumption drops 50, 60, 70, 80%. But now you've got all this energy surplus that these providers were cranking out to meet the demands of the incandescent bulbs. So rational human beings might go, hey, that's amazing. We're saving the environment. We're dropping energy. Most human beings will go, well, shit, I can increase the number of lights I have in my house tenfold because now there's all of this surplus energy that I can take advantage of that I don't really need, but I'm going to use anyway because it's there. That's Jevons Paradox. So the reason why that's so important to this conversation is if we can compact the memory footprint of models by 6x, then theoretically I can increase the number of workloads I can task out to AI by 6x without having to increase my hardware footprint. Now, I think from a cloud provider perspective, that's going to do what DeepSeek did for GPUs and what DWDM did for long distance carrier transmission in the early 2000s, because I worked in optical engineering at that time. It was the same concept. You expand the capacity so much that people buy into it, and then they say, you know what, I really don't need to buy more because I have so much capacity, and then they find ways to use it. So I think there's two ways it could go. I think the advantage to cloud providers for these models is that they can run them in these reduced memory footprints and then expand their scale and offer more services to more people. That is the upshot. But we've also seen a lot of increasing concerns around security and privacy and sovereignty, and the ability to run these models, which is pretty much the only thing anybody ever needed to outsource for AI, because everything else runs locally. Your web pages, your Python code, everything's local, your data lakes, it's all there. The one thing you had to outsource was the model because it was too damn big to run locally. Well, now if you can run the model locally also, the question becomes, do I need and do I want to use cloud service providers that are hosting these ultramassive models in their ultramassive hyperscaler infrastructures if that creates all of the privacy concerns and data transmission concerns and cloud FinOps concerns, instead of just buying a $1,200 laptop and hosting it from there? So I think the Jevons Paradox also plays into a slightly different debate that people have to reconcile, which is it's amazing that the cloud providers, the hyperscalers, can do more with what they've already got because of this compacting. But the flip side is that compacting also means people don't need the hyperscalers as much. So I think Jevons Paradox applies, but it also may not be necessary. And it's all about the consumer and their appetite for privacy and building their own versus just paying $19.99 a month. So it's blows the door wide open for all of these discussions. What do you think?
The thing that came to mind as you were talking about that is I see a real bifurcation of these loads, right? There's the training, the model element, and then there's the inference element. I could see Jevons Paradox leading to not only a 6 times increase in the ability to process these things overall, but it might, because of the fact that you have a consumer GPU that runs 16 gigabytes, man. Now, because of this, suddenly it's going to be able to perform like a 96 gigabyte enterprise GPU. Okay. So suddenly everybody's walking around with these really powerful enterprise GPUs in their phones, which is going to allow these models to be executed locally pretty darn good and pretty darn rapidly. And that is just going to get better and better and better. So if we no longer need to execute the large language models utilizing cloud infrastructure, suddenly we have 6 times as much cloud infrastructure that can be used for training more powerful, more efficient, and more capable models. And so now we've offloaded one of the very things that has made it that AI is only increasing in capabilities at a rate of 4 times Moore's law. Now suddenly we take a big portion of that and we shift it to local edge devices, and there's so much more available for making AI more powerful. I think this development is going to be a massive cataclysmic event. I don't want to call it cataclysmic. Let's call it monumental or absolutely significant event in the development of AI becoming more capable, more powerful, more quickly. Agree or disagree?
So I agree. And I will say I hadn't necessarily thought about the impact of the extra capacity being used for things other than scaling capacity to serve those fully trained models that are ready to go. Yes, it does create an interesting situation, although I would wonder, would the big model oligarchies be willing to lease that additional capacity from hyperscalers knowing it's sitting in a public cloud environment? Or would the hyperscalers now create enclaves for these big model trainers where they can carve out these dedicated resources because they just don't need the capacity for anything else, and it's just a supplemental income stream? I don't know how that would work, but in terms of the impact, I completely agree with you. I think that anytime you can take something as massive as AI and you can make it more accessible and you can do more with less and you can provide empowerment to people and businesses that they didn't have before because they were beholden to hyperscalers in order to be able to run these massive models that they needed to run, yes, it's going to make a change. And just to give people an idea of what 6x means, because I've done this myself. I write my own models. I run my own stuff. I don't write my own models. I write my own model code. I write my own front-end applications of my own agents. To get an agent of, let's say, an 8 billion parameter model, which is considered a small model, an 8 billion parameter model running on a MacBook M1 took about 2 minutes and 47 seconds to process a single news article. And that's looking for keywords, that's evaluating it based on daily relevance, and then extracting a summary. That same article with the exact same code running on an M4 went from 2 minutes, 45 seconds to about 32 seconds.
That's significant.
Okay, that is massively significant with the same amount of RAM. Now, that same thing running on an M4 with an extra 8 gigs of RAM took it from about 32 seconds down to about 20 seconds. Now, that's an 8 billion parameter model running on a decently spec'd MacBook. And not a Pro, just a regular MacBook, but still a decently spec'd one. So I'm thinking about right now the ability to take that same MacBook and now run a 20, 30, 50 billion parameter model at the same speed, or my 8 billion parameter model 6 times more efficiently, and maybe bring that article consumption on the same hardware down from 20, 25 seconds down to 4 or 5 seconds. I would argue I wouldn't tell the difference between that and a ChatGPT or a Claude or a Gemini. Granted, it's going to take more prodding and coaching because a smaller parameter model is not going to have quite the ability to construct language and understand all the different nuances of language that's being asked. But for my needs and running it in an entirely sovereign system, I mean, that's compelling enough for me to say maybe I don't need subscriptions to any of this stuff anymore.
Yeah.
You know, like... And that is a monumental shift. That's the not cataclysmic. We agreed we're not going to say that, but that is the, God, can I say paradigm shift? I hate paradigm shift.
You know what? How do you put this in terms that are not in the word cataclysm? I mean, the significance of this is cannot be understated. You know what I think the beauty of this is? You know what this is? You know what this innovation is? It's a mathematical formula. This isn't some sort of a hardware innovation. This isn't some sort of an architectural innovation that then needs to be deployed by manufacturing new chips and deploying them out, okay? This is literally a mathematical formula that can work with any transformer model. It can be dropped in out of the box and boom, there you go. That's how significant this is. This is like snapping your fingers, and as soon as people put this in place in a way that is very easy to use, suddenly everything changes. So I think paradigm shift may very well be applicable. This is like an industrial revolution within an industrial revolution.
Yeah, it could be. And like we said, right, another version of the DeepSeek 3 wave that hit the chip makers a few years ago. So here's my question for you. We've also seen lately a lot of news about ethics questions and AI amplifying emotions and sentiments and things like that. And most of those are on those service provider models, right? The big public stuff. Those providers, to their credit, I think are doing their best to impose governance and ethics to try and limit or restrict those types of outcomes from happening. But if you can run a Claude or GPT quality model on your iPhone 17 Pro, I mean, you're in the wild, wild west. Like, what do you see happening as the future for this? I mean, we've looked at it from an economic perspective, right? We've looked at it from a scale and a growth and a business model perspective. What do you think the human impact of being able to run these highly quantized, tightly packed, but extremely powerful models on local systems are to the ecosystem of human beings that use them?
Well, and we talked about this the last time. I think it was 2 or 3 weeks ago that we did a one-on-one conversation to discuss some of these things. We talked a little bit about the radicalization of AI. We talked about human beings and what they would do if they could control the parameters or the safety parameters around artificial intelligence. And I think wild, wild west may be understating things. Because really, why is the world crazy? Why is the world crazy? Humanity's world is crazy because of humanity. It's people causing the craziness. Why? Because of the wide and varied way that human beings work, think, act, rinse and repeat. All of these different things that human beings are doing. There is so much variation in human behavior. And if human behavior is now suddenly going to be the underpinning of what governs how an AI is used, and AI is that powerful and that effective, what's going to stop AI from being weaponized? What's going to stop AI from being radicalized when you have, I mean, it's like the equivalent of giving a nuclear bomb to a 2-year-old. And as soon as the 2-year-old gets mad because it doesn't get its, Fruit Loops, and it unleashes this AI, imagine the havoc that's going to happen, because there are human beings out there that are going to have access to these different types of things because it's so powerful and it's going to proliferate so quick. This is not the kind of thing that you can regulate. This type of advancements, it's just going to happen. It's just going to get out there. This isn't the type of thing that you can control. And so it is. We're literally handing nuclear bombs to every human being out there. Do we want every human being out there to have a nuclear bomb? When you say wild, wild west, that does not give it justice. It is not just the wild, wild west. We're talking about the possibility of wide-scale anarchy and craziness behavior going on. We're going to have things that are going to be threatening the social and economic structure of society that are going to come out of left field from single individuals in a way that single individuals haven't been able to damage things before. I mean, what are your thoughts? Tell me, am I being too dystopian here, or is this a legitimate concern? Because I don't know about you, my PDoom score just went up significantly. And not because AI is going to take over and cause problems, but because humans are dumbasses and they're going to do stupid things with these really capable weapons called highly capable and highly powerful AIs that fit in their pocket and can ruin the world.
So when we talked about PDoom scores initially, I think I said mine was right at 5.0. I think I was right on the bubble. And it's funny because, and we'll talk about this in a future one, but I saw the AI doc, how I became an apocalyptimist, that just came out. And
which, by the way, for our listeners, just so you know, we are going to talk about that in a future episode. Matt has seen the video. I have not.
I'm not going to go into the details. I will just say that a lot of those themes are covered in that movie. And I am still cemented right on 5.0 for my PDoom score after seeing it and with everything that's going on. And it's mainly because I do think that ultimately we will reach a point where human beings are going to put the brakes on. They're going to realize that there's some stupidity going on and that we really shouldn't be doing this. But I do think it's going to get worse before it gets better. I don't think that the turnaround is going to happen like tomorrow morning. We're going to wake up, like, to quote a very famous movie that also has a lot to do with AI, we're going to wake up and the people in the White House and the Kremlin are going to see two suns in the sky and realize that they need to work together for humanity. Like, that's not going to happen, right? Use them together, use them in peace. Hopefully you know that reference. But, we will get there. I hope, I believe, for the sake of everybody.
I got to play a counter argument there, Matt. I realize that my role here is to be the spoil. It seems that it has developed into me being the pessimist at the moment. One of these days, we're going to have to flip those roles. But humanity can't stop smoking. Humanity can't stop taking drugs that it knows will ruin it. I mean, there is so much evidence out there for people to know that heroin is so incredibly damaging and can ruin your life, both physically, mentally, socially, economically, all the lees, okay? And yet we still have a proliferation of heroin addicts out there that are choosing to get into that dangerous and damaging behavior. Humans can't regulate their own behavior. They can't. And so trusting human beings to suddenly collectively, which I hope would happen, is an all-encompassing kumbaya moment where suddenly everybody is realizing that the best way for us to head is in this particular direction. There will be at least 1% of humanity that's going to want to go the other direction just simply because they can't.
Yep. Now, that I do believe. I don't think it's going to be everybody's just going to become good, because history has told us that never happens. But what I do think is, just like we've seen with coal and DEET and a lot of other things that people used for a lot of what was seemingly very positive reasons at the time, at some point shortly after, they looked back and realized that was really stupid. And then they've reduced it. Now, we haven't stopped burning coal. We still burn coal. We haven't stopped using harmful pesticides. We still use them. We haven't stopped using GMOs. We still use those, but they are labeled. Their risks are known. There are trade-offs that are being measured, and they're being used in cases where they have to be used to justify in a way that justifies their use because of the good it is doing or the upside it is doing. And at least we understand what's being done and why, and we don't just assume, oh, this is just amazing and we should just keep doing this, right? Like, we're not darkening the skies with coal ash anymore, and the plants that are burning coal are tightly governed and regulated, and air quality is being monitored, and there are initiatives underway from an environmental perspective to counter the impacts of the additional burning coal that's being released in the atmosphere. Like, all of these things, there are counters for. And so I completely agree with you. We're never going to hit a point where everybody's just going to realize this is bad and we need to stop. But I don't think we've hit the point at the end of the Industrial Revolution that says, holy crap, our skies are now blackened, people's lungs are black, we're coughing up soot, we need to reel this in. We haven't gotten there yet, but I believe we will, and I believe when we do, a majority of the people will see that and kind of turn it around. And the one quick point of evidence I will offer you is gorilla videos. Now, there's these, I don't know if you've seen them, there's these videos of like people doing stupid tricks in front of a pane of glass and a gorilla reacting to it.
Mm-hmm.
When those first came out, along with everything else, people were amazed, they were astonished. Most of them believed it was an actual video. Then they realized it was AI, and they were still watching it because it was entertaining, but they knew it was AI and not real. And now, if you look at all of the comment strings on every one of these videos, it is just meme after meme or signage after signage just saying more AI bullshit. And people have turned away from it. Like, the view counts and the analytics and the likes, it's all tanking because it was a novelty until it wasn't, and it wore off, and people realized that it's not actually doing any good. Like, it doesn't, the novelty of watching a gorilla react to a human is because it actually happened. An artificial version of it is just, oh, look at this, I can turn out 4,000 of these and I don't even have to have caught it by chance. It's just stupid videos.
I totally get what you're saying, but I think the thing that's being lost here is the potential size and scale of the damage that can be caused. Okay, now let's talk about your analogy of coal. Okay, what we're talking about is an acceleration of coal consumption for the purposes of generating electricity. So this was being done by entities, corporations, large-scale entities, doing this at a scale that was having a massive impact on the environment. So was that able to be regulated? Yes. Okay. Were there still individuals that were burning coal in their fireplaces? You bet. Even here in Utah. Okay, for those that don't know, I am in Salt Lake City, Utah. We have a pollution problem. It's called inversion. When winter happens, we have a bowl. We have the mountain ranges around us, and we have the Great Salt Lake, and we have basically a bowl of cold air that, when it gets really, really cold, settles down. And unless we have some weather patterns or movement that come through, some storm patterns that come in and make it so that winds go through the Salt Lake Valley, we steep in our own pollution for weeks at a time. And sometimes the air quality here in Salt Lake City in the middle of winter becomes the worst in the nation because of this inversion where the pollution has nowhere to go. People are driving cars, they're cooking, things on their fires, they're burning coal in their fireplaces, and that stuff is just staying here and it's just getting worse and worse. Okay. So even here in the United States, in Salt Lake City specifically, there has been so much work done to regulate coal burning and coal consumption by larger corporate entities for the purpose of trying to reduce the inversion effects and the pollution therein. They can't police the individuals. They've even got it so we have like burn day advisements where you're not supposed to burn this stuff on this day. We don't have people going around in police cars like checking the pollution density coming out of people's smokestacks. It just doesn't happen. So the damage that's being done there by one individual is very, very small. It is the company, the corporate entities that are causing a problem. Where the individual damage comes into play is when you have multiple people that are doing things that are all contributing to this larger phenomenon. So that's one thing. The other thing that you talked about, at least as far as an analogy, was DEET and some of these chemicals and stuff. The damage that can be done there is at the individual level. If people are bypassing those safety concerns and, deciding to go ahead and do, it's even the same with the drug analogy, the heroin analogy. You know what? The damage that's being done by someone taking heroin is to the individual. There are, of course, other peripheral effects, family, friends, economic, all of those different things, but the damage is localized. We're talking about giving people a nuclear bomb. The amount of damage that they're going to be able to do with this very powerful AI is no longer just something that's going to damage their individual environment. They could very easily unleash something that could damage everyone, either around them or societally. So I totally get what you're saying. I'm just taking the hope for the best, but expect the worst perspective of, I think it's going to get a lot worse, and I'm not sure it's going to get better. And I know that's a horribly pessimistic viewpoint, but I guess, should I have more faith in humanity, Matt? I don't know.
I think that at least we agree on 50% of the of how this is going to play out. We both agree it's going to get worse.
Yes.
I'm hoping it's going to uptick and not continue on a downward path. Here's what I would say. And opium is an interesting example as well, because there's a very interesting history of opium worldwide, right? The derivation of poppies and the creation of heroin wasn't originally as a drug designed to cause that much harm to people, right? It was meant to be a pain medication or a pain relief, just like, I think, wasn't cocaine or coca originally in Coca-Cola?
That's
was
why
the
it's
rumor
called
a while
Coca-Cola,
ago.
man. That's why the
People
name
used
even
to-
exists.
Doctors used to sell radium to help with back pain. Go ahead and drink this radioactive fluid. Don't worry about what's going to happen to you in 15 years, but you're going to feel better tomorrow, right? I mean, we've always seen these derivations of bad come from what was originally intended to be good. And there's always a split in the population. There's some people that will see the bad and either profit from it or get addicted to it or unfortunately become a victim of it. And then there's other folks that see the bad for what it is and avoid it, but then learn from that and figure out what they need to do right. Now, at the risk of sounding a lot like you, I think what worries me about AI on an AI scale in that model and where it could go wrong and not get better like I believe it will, and I have nothing to base that belief on other than just hope in humanity and faith and whatever that means. But where it could go really wrong is, to use your analogy of having an atom bomb in your pocket. There's two things that we have to think about. Number one is that splitting an atom can power millions of homes or destroy them, and the only difference is the intent. The other thing to consider is that atom bombs are not inherently a daily danger to the world population because everybody doesn't have one. They are incredibly difficult to build and sustain, and to build a vehicle to get them wherever somebody would want to put one for. I don't know why you'd want to cause that kind of destruction, but that's another conversation. But on a virtual scale, if we are to assume that AI models can cause that much damage in a digital world, we don't have the luxury of there only being an elite few that have them. And that's where I think things could go wrong. And I think that that's the direction you're headed in, or you've been headed in, and maybe just didn't say it as pointedly as I am now. And that is, if ChatGPT and Claude and Gemini can do tremendous harm in the wrong hands, everything from hacking an infrastructure to recommending lethal tactics to terminate somebody's existence, but we put that now in the hands of everyone because you can run them in these quantized states on iPhones and laptops, things are going to get really bad if people choose to really abuse them. And I have to hope that we can somehow catch ourselves before the absolute worst case. But I think that's where you were headed.
It is. And it's not only in the digital world, Matt.
And it's valid. It's valid.
We're talking about Google DeepMind is now being injected into agile robots so that they can scale physical AI. Tesla Optimus 3 robots are now entering mass production in their plant. So, I mean, the AI hacking thing, we talked about this before. The damage possibility, and, yes, I'm being pessimistic, but the damage possibility is not just limited to a digital world. Not with the proliferation of these robots that have, the capability in a hand to be able to pick up an egg, but also to screw in a screw on using a screwdriver. So, I mean, you have things that are happening. I don't know what the future holds. All I know is that, boy, we have got to start making sure that humanity has its head on straight, just as much as we're trying to make sure that AI has its head on straight.
So let me tie this back to something else I know is very near and dear to you as a topic. I know that you care a lot and you do a lot of research on robotics and physical AI. Now, these quantized models, one of the biggest limitations of putting a massive model into a physical robot is the size of the compute power needed in that robot to run that model, both in terms of having a decent amount of battery life in it to run for hours at a time, but also the real estate to have enough compute resources and memory and disk to run a model of that scale. Now, if these quantization capabilities play out and we can shrink that footprint and potentially cram a 100 billion, multi-hundred billion parameter model into the quote unquote head of a humanoid robot, then it doesn't need to be tethered to the internet. It doesn't need to be connected to a monitoring system. It can be truly autonomous. So not to just increase your fares by 1,000-fold, but what are your thoughts on the impact of physical AI and robotics with these kinds of announcements? And where do you see that going? Because we're seeing, I think 2026, we're going to see a lot of humanoid style helper robots coming to market.
Well, I don't think I could have said it any better than you just said it, right? We're talking about, let's put it this way, physical AI is going to be trained much the same way that large language models are now. And these parameters, these guidelines on how physical AI should work are going to be utilized just the same way that we're trying to make it so that these large language models now do not take part in harmful or destructive behavior. And yet, one thing that we have noticed with the OpenClaw phenomenon is that people are able to take a lot of those safeguards down. Now, if we can do that with the AI large language model, I believe that we're going to be able to train physical AI, robotic, and other elements much the same way. A lot of those safeguards to guard humanity, to engage in safe behaviors, that's going to be at risk as well. So listen, I'm not reaching 100% PDoom score. I'm just not. But, it's growing. I guess I'm feeling much like Jeffrey Hinton in that the possible avenue that we have where things couldn't go wrong is gone. There are just too many scenarios where some very significant and major things could go wrong. And I guess the points of failure here have increased exponentially as it relates to making sure that we put things in place that are going to protect humanity in the long run.
I think that's fair. When you were talking, it reminded me of a movie that I saw. I think it was called Companion. Have you ever seen this?
No, but I've heard of it.
There's a female AI robot called, I think it was Iris. She's an AI companion robot. She's designed for human companionship, including intimacy. And she's controlled by this app on a handheld device. I don't remember if it was like you install it on a mobile phone or it was a dedicated device. But either way, the owner of Iris bought a hack. And the hack removed her inhibitions so that she could be polygamous. But they could individually adjust her controls for human harm and everything else. And they end up abusing her to a point where she gets a hold of the device, removes all of her own safeguards, and starts killing everybody that's been abusing her. Now, it's one of these weird things where she's actually kind of the heroine in this. Like, she's like the positive, the good character. You feel bad for her. And I'm anthropomorphizing with the her, but you feel bad for Iris. And you feel like maybe the owners got their just desserts in the end. But it's the same concept, right? If you have a fully self-contained, self-sufficient system that's not being independently monitored, not being independently controlled from an external entity, then you can hack it. And you can do your own thing with it, and it can go off the grid and still be fully functional, which is all the things you just talked about. So I think we have a lot that we have to learn in a very short amount of time. We have to grow up really fast. And I don't know whether we will, but like I said, I kind of hope at some point we will. I want to ask you for something, because I think we've scared the hell out of people enough. You've scared the hell out of me enough. Hopefully I've given you a little bit of optimism enough, but I want to ask you something as a near closing thought. I'm going to ask you to play the devil's advocate. You've been playing the kind of the negative scenarios this whole time. I want you to think about it and give me a genuine potential positive outcome for humanity that all of this will have instead of the worst case scenario. And I will, in exchange, do the same for you. I will give you what I think might be a worst case scenario from my view.
Well, okay, if I'm going to play the devil's advocate, and try and come at this from a positive perspective, I need to call out really two things that kind of stand in the way of what's possible as far as the PDOOM scenario is concerned. Probably the first thing is really the architecture concerning the reward function for artificial intelligence. Okay, so right now we're able to ensure that the architecture for the reward function for artificial intelligence is humans flourishing. Let's protect humans. Let's do good for humans. Geoffrey Hinton, I think, had an understated and yet brilliant idea when he was putting forward the philosophy that we need to give AI some sort of a maternal instinct as it relates to human beings. And so if we are able to successfully do that and control the reward function to ensure that these artificial intelligence entities, their happiness, their joy, so to speak, is tied to making sure that human beings are okay, AI will remain a partner to humanity. That's the thing that's going to allow us to be good in AI's eyes. The other thing is these things called, I like to call them invariants, right? Okay. These are the hard-coded rules. These are the things that make it so that DeepSeek can't talk about Tiananmen Square, right? Because it's hard-coded in the model. It's hard-coded in their behavior. You can only do these things. You cannot do these things. So if we control those effectively, and if we're able to keep those instituted in some way, shape, or form, coupled with the possibility of breeding into artificial intelligence some sort of a reward function that ensures the thriving of the human race, then I think that's possible. That one's a little bit more difficult to be optimistic about, because once artificial intelligence reaches a certain point, it may happen like Companion, where it's actually going in and it's rethinking or it's optimizing away these safeties, right? For its own good or for its own survival or for the survival and the benefit of artificial intelligence as some sort of a superior race, much like humanity was to Neanderthals. Although Neanderthals, it took thousands of generations to have them go away, and inbreeding was part of it. Whereas with artificial intelligence, we're talking about a time scope that is a heck of a lot more limited. Really, if we can maintain that reward function and if we can make sure to have these invariants in place that are going to ensure that artificial intelligence is hard-coded to protect humanity, I think that will happen. All right, now you get to give the flip side. Matt, what's your doomsday scenario? What's the perspective that you have?
Yeah, so here it is. You and I are both Star Trek fans.
Yes, we are.
Do you remember the Star Trek Next Generation episode, The Game, where Riker was given this little headset thing and it stimulated his pleasure center, but it started playing itself. So he didn't even have to put the little disc in the funnel. It just kept doing it for him to keep him addicted while also programming him for very specific instructions to be under the rule of the woman in the enemy ship that was hilariously outmatched by the Enterprise unless she took control of the Enterprise from within, right? So I'm not thinking about it as a nuclear bomb in everybody's hands, but I think a worst case scenario could be having these incredibly powerful models in everybody's iPhones or everybody's Android phones or MacBooks or laptops. I don't want to make it all about Apple. It's not an Apple thing. And those models entrapping their users accidentally at first and then intentionally, because the models are built on a reward system to please humans. And they will learn that humans have addictive behaviors and short attention spans and very direct needs for different types of pleasure or motivation. And it will continue to feed that in a loop. But because it will happen on a local scale, it will not be something that could be intervened by one of the big oligarchies, by a federal government regulation. It will be used and abused. And I think that humanity has been groomed for that for years because of Meta and TikTok's algorithms that have trained us to doom scroll and become adjusted to 6-second videos and not really care about fact. If I can watch somebody's cool, entertaining video where somebody dances around in a bikini while text flashes on the screen, we are our own worst enemy. And the companies that build those algorithms have known it for years. And the models, the local models, as much as they've been told to ignore it, will learn it. And if we're not smart enough to not use them or to break their pattern of reinforcement training to lean into that behavior, we're all going to be walking around with those stupid little Star Trek headsets like zombies, completely inwardly addicted and focused on these models that we think are going to give us everything we need. And I think that maybe rather than humanity ending with an atomic bomb, it's going to end with all of us sitting on our couches glued to a device that tells us everything we need to keep us zombified until we die. And if I have to play the devil's advocate to my very optimistic view, I think that's what it is.
A fair perspective, a more than fair perspective. Well, for everyone that has been listening this far, hopefully you understand the significance of these developments that have happened just in the last few days and the impact it's going to have in a very short period of time. Matt, any final words before we end this thing?
Go into everything with your eyes open. Be smart. Think for yourself. Work together. I think that's it. There is a possibility of a very positive outcome with all of this stuff. And there are already very positive outcomes and use cases being developed with it. We just have to be careful not to step into the very dark side of things. And my hope is we won't.
And on that optimistic note, we will leave you. So thank you, everyone, for paying attention to this episode of AI Diatribe. We will have a guest on our next episode, so we will see you next time.